Hey math lovers, let's go over stats 1.7, measuring variability, how data varies. Learning targets after this lesson, you should be able to, number 1, find the range of a distribution of quantitative data. Number 2, find and interpret the interquartile range. And 3, calculate and interpret the standard deviation. All right, so let's go over what these are. So there's four measures of variability. There's the range, there's the interquartile range, range. 3, there is something called the variance, or the variance, I'll put in this one because I have 2 blanks, and the other one is called the standard deviation. So there's the 4: range, interquartile range, standard deviation, and the variance. Let's go over the range. This is the easy one, but not always the best. The range is the full spread of, I forgot a word in there, all the data. And what is your formula? You had this from before. It is the maximum value, max, minus the minimum value. So you take the biggest number subtracted by the smallest number. All right. What are percentiles? Percentiles are the value in the distribution such that P, so it's an unknown, like a variable, percent of the observations lie at or below that level. For example, if you score in the 90th percentile, that means 90% of the data lies at or below the data point. So percentiles, these are applied best in standardized tests like the SATs or the PSATs. Let's say you're in the 90th percentile. Here's mine. This is everybody. And let's just say there is 90%. And this is you. That means 10% scored above you, but that means 90% scored below you. So that's a quick idea about percentiles. What are quartiles? Quartiles, I want you to think of like quarters. Okay? Each of the 4 equal groups into which the data set can be divided. So if you are in the 25th percentile, think about it, 25 cents represents kind of like 1/4. Does that make sense? The 50th percentile, we call this kind of going from cents to quarters, that's the second quartile. So 25th percentile, first quarter, 50th percentile, second quarter. What do you think that means for the third quartile? That means that the 75th percentile, 75% is a good way of thinking about it. And that means the 100th percentile is the 4th quartile. Okay, what is the first quartile? They're going to abbreviate that. Get in there. And so they're going to call this Q1. First quartile is going to be Q1. This is the middle of the lower half of a data set separated by the median. And then, sorry, that a lot of typos. This one is the third quartile, which is Q3. The middle of the upper half. of data that is separated by the median. And then the interquartile range, IQR, so IQR, it is the middle 50% of all the data. And your formula for the IQR equals Q3, quartile 3 minus quartile 1. Okay? All right, so let's go through an example. This might make more sense. Animal speeds. The table shows the animal speeds measured in mph, miles per hour. So there's our animals. The first thing we're going to do is find the range. So the range, so in math, don't think, statistics is a lot more critical thinking. It has context or a story, but you still have to do math. So what do you always do? Always write down the formula. The range is equal to the max minus the min. So you'll get credit just writing down the formula. So let's go ahead and look over here. Which one is the highest and the lowest? So 70 minus 1. You're going line by line, showing all your work. So the range is 69. So you can actually say that the animal speeds, you don't have to, this will help you with context. The animal speeds, let's use the keyword today, varies, or there's a range or different values by 69 miles per hour. Okay, question number 2, find the median. So again, this goes back to what we've done before. I'm going to have to write all those numbers from least to greatest. Okay, let's do it down here since we have a little more space. I'm going to do 1, 8, 25. So let's check them off as we go. 30, 50, and 70. So there are how many animals? 1, 2, 3, 4, 5, 6. There's 6 animals here. So the median is right here where my line is. Do you see that? There's 3 numbers to the left, 3 numbers to the right, so it's in between the 3rd and 4th numbers here. So we basically just have to find the average of those 2 values. 25 plus 30 divided by 2, so that gives me 55 divided by 2. And this will give me a 50, 25, 27.5 is the median. Okay? Okay. Let's see if I can color code this very clearly. It's going to be super important. Okay. Now it tells me mark all the numbers below as the lower quartile. So I should have done green. So the lower quartile is these numbers down here. It's below the median. Okay, and then it says the numbers that are greater than the median are called the upper quartile. So I'm going to highlight that in pink. Numbers that are greater are called the upper quartile, so that's over here. Let's write that. So this is called the upper, and this is called the lower. Okay, so we did that. And then find the interquartile range. So that again is the IQR. That's going to be Q3 minus Q1. Okay, let's find the median of the median. So I'm looking at the lower half, the lower quartiles, and I basically need to find the median of that. And that's right here in blue. So we can call this one the lower quartile, or you can also call this one Q1. Okay, so let me write that. Quartile 1 is 8. Let's use a different color. Let's use red. So again, I'm looking at the upper quartile, so those three numbers highlighted in pink, and I need to find the median of those three numbers. That would be 50. So this is the, can't see that, huh? UQ, upper quartile, and this is my Q3 value. Okay, so let's go over here. Q3 is 50. So that means my IQR is 50 minus 8, which is 42. The IQR for our animal speeds is 42. Let's go down now to the next page here, and Pokemon cards. Go ahead and press pause. You try it, and then I'll go over it step by step. Alright, the given list is a number of Pokemon cards each kid has. 3, 12, 17, 2, 21, 14, 14, 8, 45, and 31. So what am I going to do? I'm going to list these in ascending order, least to greatest. So I see 3. See 2. I see 8. I see, whoa. I see 12. I see 14, 14. 17, 21, 31, and 45. Okay, I'm going to go back and just double check that all these numbers are there. I'm going to just count how many numbers are here. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm going to say n is equal to 10. N just means how many numbers are in our list, how many Pokemon cards. Okay, think about it, you have 10 kids. So I need to have 10 numbers down here. Okay, so to find the range, all I have to do is just simply find the max minus the min. So my max is going to be 45, and the minimum is 2. The smallest number on that list is 2, so my range is 43. So we can say that the Pokemon cards has great variability. What does that mean? Great spread, the amount of cards. Some kids, kid number 1 has only 3, and kid number 10 has 45 Pokemon cards. That's a big range. It's a big spread. That's a big, it's not like all the kids have 7 Pokemon cards. There's a big variety of variability there. Okay. IQR. That'll be Q3 minus Q1. All right, so there are 10 numbers, so I need to have 5. 1, 2, 3, 4, 5. So you'll notice that there are 5 numbers to the left of this orange line and 5 numbers to the right. Now, because this is an even, you're going to have to find the average of these two numbers. What is the average? Hopefully you can do it in your head, but you realize that it's just 14. The median is 14. Okay, now pay attention. Let's highlight it again. What did we do last time? Green and pink. Okay, so this is my upper half, and this is my lower half. Okay, so if you just put your finger on the median of what I just underlined in green, the median there is 8. That is my Q1. Let's write that. Q1 is 8. Oh, I didn't want that. Go away. Yeah. Okay. And so let's label that. That's my Q1. So another way of explaining it, again, is if I just took kind of like did two separate problems, what's the quartile, what's the median of the green numbers there? And there's 5 numbers, so it's an odd. You just pick the number in the middle. It's 2 to the left, 2 to the right. Okay, what is the median of the ones in pink? Well, there's 5 numbers, it's odd, and that would be, whoa, wrong color. That would be 21. 21 is the quartile 3 there, because it is the median of the upper half of numbers. Okay, so let's write that over there. All right, so now that I have those numbers, let's go ahead and check them. 21 minus 8 is 13. The interquartile range is 13. Double check that. That is correct. Okay. Let's move on to a more complex idea of variability. And this is the word standard deviation. All right, let's go over what standard deviation. Standard deviation is a measure of spread. And if you guys remember from before, my example is what? Toast. And let's just say you just plop on some orange jam right there. Orange marmalade, okay? The easiest definition I can give you is that standard deviation is the average distance the numbers in the set are from the mean, the average. Okay, if all of the numbers are the same, if all the numbers are the same, the standard deviation would be 0. There's no spread, there's no variability, there's no different numbers. Okay? The standard deviation is consistency. And the question you can ask is, are the numbers close to each other or very spread out, kind of like jam? If the numbers in a set are all very close together, then it means you have low variability, like variety, you could think of it. And the standard deviation will be small. If the numbers in the set are very spread out, then you have something called high variability. And the standard deviation will be very high. I'll use my toast example after our next one. And this last one, standard deviation is not resistant. We'll talk about resistancy in the next lesson. To outliers. An outlier in either direction will make the standard deviation larger. Okay, so if you have some toast and you try to do your very best to kind of spread it out, right? Spread, variability, right? But it also varies what kind of toast you have, right? Let's just say you're in a hurry and you have that jam right there and you're like, I don't really have time. You just plop it on there. It just stays right there. the spread is very low. Low spread, right? The jam's not really going anywhere. It just stays in one place, okay? And then if, you're that perfectionist, like, oh my goodness, you have that, I forgot, that thing where, like, you sit there for, like, the first hour and then you spread it out, right, perfectly, and you go over it evenly over and over again, and, like, you want every little, like, spot to be perfectly covered, right? You're, like, going it over and over again. You're having it's spread out, but in your perfectionist, like, there's certain areas that have no jam, and this area has too much jam. All right, let's see if we can get a visual to this, okay? Let's draw a dot plot to help you understand this. So this is my distribution, just another graph, okay? What happens if I drew a bunch of dots like this? My question is, that question that we had under here, are the numbers close to each other? Are they spread out? Okay. Well, let's draw a different one. What do you notice about our pink one compared to the blue? Well, in pink, the spread is small. And what do you think my standard deviation is going to be? Small. It doesn't deviate away, and our variability is low. It's close together. But the blue cyan, the spread is really spread out, right? The jam is really spread out. So your spread is large. Your standard deviation is large. And variability is large. I have another quick example. Maybe this will make more sense, right? Certain schools have uniforms. And everybody kind of looks the same. Right? The variability in which people wear their clothes, what people vary and what they look like is very small or low, right? There's not a big range, big spread of different outfits. But at certain schools where it's open, there are no uniforms, like, people look all different. The variability, the spread, it deviates away from each other. You guys don't look the same. You all look different. That's a large possibilities of different wardrobes and what am I trying to say? Different wardrobe, different looks. Okay, so let's try this. Let's try this. Let's try this next problem. Both histograms have the same mean and median. So there's no numbers, but they're telling you they are the same. Which one has the smallest deviation? Okay, so the first thing I want to do is mark, let's write that. Mark the center. Let's do that with a highlighter here. Okay, let's mark the center, okay? The center is here. There's the middle of our distribution. So, 4A. Question. Let's go back up to the question up there. Are the numbers close to each other or very spread out in A? Well, all that data is very close to that blue line. So we can say that in histogram A, has more data, clustered means like together, clustered around its center, around its center. Which gives it less or a lot? Less variability which results in, is it a large or small spread? small standard deviation. Right? All the jam is it's pretty close to the center here. It's not really spread out. There's not a lot of data. Okay, so let's underline those words. Small, right? It's clustered around it. It's less or small variability. Okay, so what do you think we can do about B then? Histogram B has data that's close by or far away? Has more data away. From the center, which gives it what? Less or more? More variability, or more spread, right? Spread out. There's not over here, but remember, when the histogram building is here, that means there's like a lot of data happening in there. Okay, it's spread out further away. More variability, which results in what kind of standard deviation? In a large standard deviation. Okay, so hopefully that drives the point home. Let's go over the next page here. All right, question number 4, multiple choice. Without performing any calculations, so don't write out all the numbers, use the stem and leaf plots to determine which statement is accurate. Okay. Okay, A, so multiple choice, data sets 1 and 2 have the same standard deviation. So if you just look at the number of digits, what I'm trying to say is there's 4 numbers here, and then there's 4 numbers here. And then there's 2 over here, and then 2 here. 2, 2, and then 1, 1. So the standard deviation is actually going to be the same there. Let's try a different one. Data set 2 has the greatest standard deviation. Okay, so these are all spread out the same based on the number of digits, but this one's all kind of clumped in the middle. So 1 and 2 actually have the same one, so this one's doesn't have the greatest right there. Okay, and let's try C. Data set 1 has the smallest standard deviation. That's wrong because it has lots of spread, lots of numbers going there from, again, the middle. But look at this other one here. Let's highlight the middle. There's our middle, right? Look at number 3 there. That one has a lot of data here. So your spread is actually little. The numbers aren't, there's only one number here. So that one's very little standard deviation. That would actually just be choice 3. And then question, or choice D, data sets 1 and 3 have the same range. No, because you can look at the minimum and maximum, right? This one has no numbers here. This one does, and you can also look at the numbers there. So A is our correct answer. Okay? All right, let's go down to this next part here. And let's talk about standard deviation. So you have this big bad formula. Okay, let's try to color code this. Standard deviation is S. So S means standard deviation. And it is important for these abbreviations because we can actually see these on the calculator. Okay, let's look at some other things. Here in green, that symbol is called sigma. It's a Greek letter of the alphabet. And basically what it means summation. What math word do you see in there? Sum. You just need to add up the numbers. Okay? All right, let's keep going here. xi is the individual data points. So xi is the individual data point. Let's change colors here. That's called x bar. Do you guys know what that is? This is called the mean, or a simple word is average. But again, I'd rather use the word mean because it's more accurate. Okay. What other colors we got? Okay, and then the last one is n. N here just means the sample size. How many numbers do you have in that list? How many people are you talking about when you say Pokemon cards? There's 10 kids there, okay? Okay, let's look at this formula over here. Looks intimidating, but it's not. Okay, so variance is another variability, but all you need to do for variance is just find S in standard deviation and then square it. That's it. So those are your formulas. Okay, standard deviation is big and bad. We're actually going to use that. Variance, you're not really going to use that one. You are, but all you have to do is just take that value and then your answer and square it. Okay. All right. So let's do an example. Use the following ages of my kids: 1, 3, 5, and 7. Okay, it's just meant to be a super easy example. Okay, let's go through these steps. Find the mean of the distribution. So the mean is the summation of all of our numbers and then divide it by n. So what does that mean? You just take all your numbers and then divide it by, well, you have 4 numbers, right? Because you have 4 kids here. I actually have 5. So if I add all those together, 10, 16 divided by 4, that means I get a x bar of 4. Okay? All right, what do we do next? Calculate the deviation. So let's make a chart here. Let's make this really big chart here. Okay. Here is the numbers. Xi basically means I is a number. So for example, this would be x1, x2, x3, x4. It's just a number in the list. Does that make sense? So that would be, let's use orange because it started 1, 3, 5, and 7. Okay, what do you do next? So we did this one. Calculate the deviation. What's the deviation? It's the value minus the mean. So it's going to be xi minus the mean. So we already have these numbers, 1, 3, 5, and 7, and we're going to subtract that from the mean, which is here highlighted in green. So I'm just going to write down that number down that list. It's 4. Oops, that's a highlighter. So that number is going to be 4. Okay, so if you actually compute these values, 1 minus 4 is -3. Use your calculator, guys. No excuse for positive negatives. 1, and then 7 minus 4 is 3. Okay? So we just did that one. Okay. Square each of the values now. Okay, so I'm going to write out the formula, and you're basically just taking these values, we just subtracted them, and now we're going to square them. Okay, so let's square them. So I have -3 squared, which is +9, -1 squared, which is 1. 1 squared, 1 times 1 is 1. And 3 squared is 9. Okay? Now it says add up, let's use a highlighter here. Add up all the deviation. So right there, we're adding those all up. Okay? So that number is going to be 20. Whoops. 20. And then it says divide that number by n minus 1. Okay? So I'm just using the formula right here. And our n value is 4. So let's write out the formula, see what we've done so far. Okay? You've taken the values in the list and we found the mean and you subtract it by the mean. And then we took all those values and we squared them. And then you divided it by n minus 1. So that should have been 3 because it's 4. 4 minus 1 is 3. Let's erase that. And then you added up all of those values, right? That was a 20. And then the last thing we need to do is just take the square root of that number. Okay, so let's go ahead and do 20 divided by 3, and we'll take the square root. So, calculator, where are you? Calculator, there you are. And I'm going to clear that. So 20 divided by 3 gives me 6 2/3. Okay, I want a decimal. Okay, so there's my decimal, 6.667. Okay, now we need to take the square root of that number. So square root is next above top left of the 7. It's in blue, so second square root. You don't have to do exact. Okay, so I'm going to round to the nearest hundredth or thousandth, so that would be 2.582 would be the thousands. Thousands is 3 decimal places. $2.58.2. 258.2. 258.2. 2. $258.2. So we had to take the square root of 6.6667, and that gave me a standard deviation of 2.582. Okay, so that answers the question of the standard deviation. So that was only 4 numbers, guys. It gets bigger and better. Okay, so what did we do again? Write down the numbers in the list right here, and then we're going to take those numbers and subtract it from the average, which was the green over here. And then you get an answer, and then you take all those values and you're going to square them. So that's what we did in this column. And then I took in the highlighted there, I added up all the squareds and got here in circled in blue. And then you divided that number by n minus 1. So n was 4, so 4 minus 1 is 3. So 20 divided by 3 is 6.667. And then I took the square root of that number, and that gives me the standard deviation. So it is that much work. But go step by step. And let's go ahead and try another one. All right, let's go ahead and try this problem. They call this the grocery bills, buying food. And it says, has all this data and tells us to find these things. Okay, so this is actually called the 5-number summary there. But the first thing I'm going to do is I'm going to list all my numbers in order. And we have some good news. What do you notice about that data? It's already organized for us. Awesome. Let's count how many are here. 1. So that's like, remember from the previous problem, x1, x2. And that's just talking about like how many numbers in the list. So I got 9 numbers here, right? It's an odd, which is nice because we like odd numbers. Why do we like odd numbers? Because we can just find it very quickly. Okay, so I made a chart for you, but let's finish this problem. It says, what is the minimum? There's the minimum, $10.53. Let's do this one over here, the max. $52. That's a 2. Come on now. 52.36. Okay. So we said there's 9 numbers. So I'm gonna circle this one right here. That number there is gonna tell me the that's the median, right? It's the middle of all of my numbers. Okay, so median is 2089. Okay, let's use our highlighter. We did it before. Okay, so what do you do when it's an odd? Okay, you don't include it. You don't include it. Do you see that in my pink? And then I'll do this one in green. I did not include the median. Okay. All right. So why do you not include it? That's just what you do. Okay, let's take a look at the pink now. To find quartile of the pink, you basically need to find the average of, whoops, these two numbers here. So 1367 plus $15.01 divided by, there's two numbers there, and your average is going to be, this is Q1, is going to be 1433. Again, how did I get 1433? I'm just finding in the pink numbers there the median, which is in between those two numbers, right? Okay, let's do the same thing over there so we can find quartile 3. Again, it's right here. It's an even, right? I'm including the maximum, but not the median. Well, I circled an orange here, so I'm just going to find the average of those two numbers. 3282 plus 3757 divided by 2, and this will give me a quartile number. Quartile 3 is going to be $35.20. Okay, 35.20. Now I do want to, you can write this down. Let's put it up here where I have some space. Let's just say, I don't know, make up a formula here. Median position. How do you find the median? Well, if you take how many numbers in your list, you add 1 to it and divide it by 2. Okay, so in our list, we have 9. And then you use this median position formula. 9 plus 1 divided by 2 is, so 10 divided by 2 means fifth. The fifth is the median position. Does that make sense? That's why I circled it in orange. So I'm just trying to show you a different way of finding that circled number in orange. Okay, so we got all that. All right. Now we are going to figure out the average. Okay, so how do you figure out the average? Remember, I showed this to you on your calculator, and I'm basically just going to add up all those 9 numbers. So I'm going to use my calculator here, and I'm going to go to Stat and Edit. Now, again, if you want to do what I'm doing here, yes, you can use your iPad, but once we go back to school, it has to be a calculator, so I recommend doing that. I'm doing this more for presentation format. So I'm going to go up to where it says L1, and I'm going to press Clear. You can also get a graphing calculator like a TI. That's one I know how to use best. So I'm going to insert all of these numbers 1053, 1367, and 1501, 1830, 2089, 2707. Okay, so if you make a mistake like I just did, you can just put the decimal 07, enter, 3282, 3757, 37.57, 5236. Okay, so those are my 9 numbers there. So now I have them in L1, so I'm going to press Stat. I'm going to move over to Calculate and 1var Stats. And I need a list here. To get this list, it's in next to the left arrow, so I'm going to have to press Second Stat and click L1. Okay? Ta-da! My average is $25. You see an X bar on top left there. 25.36. 25. Oh, look at that! It calculated the numbers, and then on the far right there, it actually has the. Can I zoom in? No, I can't. It has here the 5-number summary that we just found in the previous problem. But I wanted the average, 25.36. So let's go ahead and put that into our notes. 25. X bar is 25.36. Okay, so let's put in all our numbers here. I have, we're going to take all of our numbers. You can write them down if you want. There is 9 numbers in the list. And those numbers are 1053, 1367, 1501. You guys got to do it step by step. Do it with me. That's why I'm recording these videos. It's just like we're in class. 2089, 27.07, 3282, 3757, and 5236. Okay, what do we do now? We're going to take our numbers and we're going to subtract it from the mean. So I'm going to have to take $10.53 and subtract it by the average that we just found, which is 25.36. Okay, so we got subtracting all that by 25.36. And then we're going to get some answers, right? So let's get those answers. All right, so if you subtract $10.53 minus 25.36, you'll realize your positive number is smaller than a negative number, so I'm going to get a negative number. So negative 14.83. This one's going to be negative 11.69. So use your calculator, just subtracting here. Negative 10.35. Negative 7.058. Negative 4.468. 1.7122. $7.46.22. I subtract those two numbers, I will get 12.212, and then I got 27.002. Okay, so let's review what we've done so far. We've taken our numbers, I've subtracted from the mean. Now I'm going to take these numbers in blue and we're going to square them. All right, so if I square these numbers, take negative 14.83 and square it, you're going to get some bigger numbers. 219.83 136.86, 136.6, square that, you're going to get 107.08. Square this one, you will get 49.812. Negative 4 point, that gives me 19.961. Square this number, 2.9317. And remember, if you're squaring any number positive times a positive or negative times a negative, it'll always be a positive. So all these numbers here I'm writing in yellow should be positive. 55.685. Square that number, you will get 149.14. And square this number, and you get 729.12. Okay, in yellow there. If you take all these numbers now, the formula is the summation of all of these values now squared. So if you add up all of these numbers here in orange, you will get 1,470.191756. Okay, almost there. So the standard deviation, the formula is S equals the summation of all of those numbers you just did squared divided by n minus 1. So if I take all those numbers, now I get 1917.56, and then our n value was, there were 9 numbers, so 9 minus 1. If you do that, if you divide first, you'll get 183.774. And if you take the square root of that number, the standard deviation is going to be 13.556. This is the standard deviation. What does that mean? That means if you have a bunch of grocery numbers, right? Maybe you do grocery shopping in your house. I used to do that. And the question is, how much is that spread? Well, the spread is going $13 in some ways in both directions. Okay, it can vary. Okay, variance. How do you get the variance? Well, remember, this is so fast. Hey. Variance is just s squared. So if s is equal to this number, if you just square it, you'll get s squared, which is variance. And that number would be, if you think about it, it's already above 183.774. You see that number right there? So that's how you found standard deviation and variance. Okay, so you will have to calculate this by hand. Okay, I can tell you take a picture of your work, turn it in, quiz or test. You got to show it to me. But let's see. Look at that number. Do you see it? SX on my screen. That means your calculator can figure out standard deviation by hand. Oh my goodness. 1356. 1356. Yes, that means it can go a lot faster. Okay. Let's see. Let's go to stat. Edit your list. So you have the numbers in that list. Okay. Let's try something. L2. I just want you to let's see. So I'm going to put all this into the calculator, and actually can calculate a lot of these values for me. So edit list, go down, and No, I want that to be L1 second stat L1 enter. No. It's kind of hard to do here. I won't do it because I can't. So a graphing calculator can kind of make the table, but you can just spit it out. And you can actually also figure out the standard deviation with your regular scientific calculator. You just have to figure out how to put it into the list. So I want you guys to go to the next problem, college history here, and I want you to do it. And then I'm just going to work it out. And so in about, when you press pause it and you press play, you'll see the whole answer there. So go ahead and try this last problem here for some practice. All right, so college history, 12 numbers. I took all my numbers, put them from least to greatest on that far left column here. And then I found the average, which is 86.5, subtracted all those values I got in orange. Then I take the orange values and square them to get the green numbers. Add up all the green values, get 481. And then take 41 divided by n minus 1. I get 43.727. Take the square root of that, and it gives me a standard deviation of 6.613. And if you just take that number and you square it, you'll get the variance. A lot of work. And you can double check with your calculator, but this is calculating standard deviation.
Hello, man.
And this is the lesson 1.7, measuring variability.